let's take a look at the opposite way. Let's look at factoring. Okay, so 4x squared plus 12x plus 9. We want to factor this into two binomials, as we normally would. But based on what we saw in the previous example there, we might be able to see a little bit of a, let's call it a cheat or a little bit of a pattern that we can take a look at. So let's see here. 4x squared, is that a perfect square? Yes. The square root of that is 2x. Is 9 a perfect square? Yes, it is. The square root of that is 3. So let's see, would this work based on what we saw in the previous one? 2x times 3 is 6x, multiplied by 2 is 12x. So what we've just done here is we have simplified the form of factoring. We've tried to take a look at some patterns to see if it works. Now, for those of you that are unsure about what we did there, let's look at, 4 times 9 is 36. And let's look at some factors of 36, which would add up to 12, and that will be, let's see here, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, it's 6 and 6. There we go, okay. Okay, so 6 and 6. So we're going to take a look at, we're going to decompose this. And now again, I'm using decomposition. Plus 9. Factor this out here. We can take out a 2x. So we're going to be left with 2x plus 3. And here we can take out a 3. And we're going to be left with 2x plus 3. And you'll notice that as we factor here, and I did this really quickly, as it's a video and I don't like to take up too much space there, they are exactly the same. Okay, what we pulled out is exactly the same. That is our perfect square. Now it only works though if we have perfect squares. Okay? And we have to understand that the first two have to be a perfect square and the middle term has to be a combination of the two multiplied by 2. So let's look at a couple more here and see if we can do these fairly quickly. Now if you want to go through and do this using decomposition, you gladly can. It just takes a little bit of time, okay, depending on how quick you go. But let's look at the patterns. Is this a perfect square? Yes, it is. The square root of 25a is 5a. Is 16 a perfect square? Yes, it is. The square root of that is 4. Now, if we multiply 5 and 4 together, we're going to get 20. We multiply 20 by 2, we get 40. So that seems to work. But the only difference is that this is a negative 40. So we have to make this a negative 4. And that would be our factored form of a perfect square. So factoring out a perfect square. Let's keep seeing if this is working. Now it has to work out perfectly, so these two have to match up to the middle one as well. Okay, if we multiply them together and then multiply it by 2, it has to equal the middle one. Let's see if that keeps working. Y squared, is that a perfect square? You bet it is. Okay, 1y, so square root of 1 is just 1, and square root of y squared is y. 16 is a perfect square. That is 4. 1 times 4 is 4. Multiplied by 2 is 8. That works. It is a negative, so we make that a negative, and that is y minus 4 squared. Let's try one more. Let's see if they seem to be still working, but this one is a little different where it has a 1 at the end. So 81, is that a perfect square? You bet it is. 9d will be our result. 1 is a perfect square, that is 1. 9 times 1 is 9, multiplied by 2 is 18, and so it is positive, so we put a positive sign in there, and it is a perfect square, so we put a square there. That is how we factor perfect square polynomials. It is something that if there is a perfect square there, we can notice it. It's really quick and easy to factor. Now again, decomposition still works. Okay, like I showed you up here, decomposition still works in this case, but we can do it a little bit quicker if we also can see it.